Good morning all. This is Daisy Merina from Wheeltech Multitech Dr. Ingaraji, Dr. Sakuntala Engineering College from the Department of Artificial Intelligence and Data Science. Today we are going to see a video lecture on RSA algorithm from the subject Network Security. So network security. First we see what is network security. Network security is an activity which is designed to protect our data in the net from the third users. That is protecting the sensitive information from the cyber threats. Okay, it includes both hardware and software. The main goal of network security is used to prevent the unauthorized access, misuses, and modification of what message we are conveying to the users, then the bank account details, what we are sharing in the net. So for all these, we have to give a security so that we are going for the network security. So next we will see about the key components of network security: confidentiality, integrity, availability. These three are the major key components of network security. The first one is confidentiality. Confidentiality means the sender will send one message to the receiver. It has to be received by the receiver, not by other third person. No third person has to communicate with the sender and the receiver. To ensure that, we are using the technique called encryption to protect the information in a good manner. The next one is integrity. Integrity is nothing but maintaining the accuracy. The sender will send one message. That message has to be received by the receiver in the same manner. There will be no alteration. The message should not be altered. The next one is availability. Availability, we are ensuring whether the authorized users are using in proper manner. With the help of this, we can remove the system failures, denial of service attacks like that. The next, we will see what is encryption and decryption. So, encryption and decryption are the fundamental process in cryptography, which is used to secure the information. So, encryption is nothing. It will transforms the readable data into an unreadable data. The unreadable data is called as the ciphertext. That is the main aim of the encryption. Again, decryption. Decryption is the reverse process of the encryption. It will converting the ciphertext back into its the original form. The next one, encryption, we will see in detail. So encryption, we know we are going to convert the plain text into a ciphertext, that is readable into an unreadable. Here we are using key. With the help of the key, the plain text will be converted into the ciphertext. The ciphertext, we couldn't read that, it will be in an unreadable format. The goal of encryption of data is to give the confidentiality for the sender and the receiver, and only the authorized users can receive the original content. No others can interfere with this. So this is the main goal of the encryption. Next, encryption, we are having two types. One is the asymmetric and symmetric. Symmetric means we will be using the single key for encrypt and decryption. So we are having so many algorithms for that symmetric also. Among the two examples are given over here. One is AES and DES. These are the full symmetric encryption algorithm. The next one is asymmetric encryption. Asymmetric encryption means in the word asymmetric itself spelling it is different. So here we are using a pair of keys. One is a public key and a private key. With the help of the public key, we will encrypt the data, and with the help of the private key, we will decrypt the data. For that, RSA is the best example for the asymmetric encryption. There are so many algorithms in this techniques. Next one is decryption. Decryption is the process of converting the encrypted data back into its original content. That is, the original message will be obtained in the end of the decryption process that is called as the plain text. Depending on the encryption size, the key or keys will be vary. Next one, here also we are having two symmetric key decryption, asymmetric key decryption. With the symmetric key decryption, we will be using the same key for both encryption and decryption. But in the asymmetric decryption, we will be using the different key, public key and private key. So public key is for encryption, private key is for decryption. The next, we will go into the main part, that is RSA. So what is RSA algorithm? What are all the components of the RSA algorithm? And what are all the working principles? What are all the steps we will see here? First we see RSA algorithm is what? So R means reversed, S means Shamir, and A means Adelman. So RSA, these three persons together frame one algorithm. These three are the inventors. So the name come to the algorithms RSA. So these three invented an cryptographic algorithm in the 1979 is called as RSA algorithm. So RSA is a form of asymmetric encryption. So from the asymmetric encryption in this algorithm, we are going to use two keys. One is public key and the private key. That is the main thing we have to keep it in the mind. The next one is this approach is different from the symmetric encryption. Whereas in symmetric, we will not use any other key, only we will be using the same key for both encryption and decryption. But here the working principle will be different. So next we will see the components or say components. What are all the components we are going to use here? The first one is public key, private key, then modulus, then exponent for both private exponent and public exponent. These are all the five RSA components we are going to see in detail in the next upcoming slide. Next, how RSA works. So the first step is the key generation. Next one, the public key, then private key. So key generation, we are using 2 to 3 formulas to find the private key and the public key. That we will see in the next slide. So first step, key generation. Here we are going to see the 5 steps. The initial, we are going to choose two values, okay? The two value has to be in the prime numbers, P and Q. We can use large prime numbers. If we are choosing the large prime numbers, the security will be in high manner, okay? The next step we will product will go with the key values, that is compute modulus function n. The next step is we will be finding pi of n with the help of the Euler's Torsion function. So pi of n equal to p minus 1 into q minus 1. The next step we will be choosing a public exponent e value. Then last we will find d value. D is the private exponent, that is the multiplicative inverse of modular. Okay, these are all the 5 steps which we are going to use to produce a keys. The next, so next we will see encryption and decryption. So with the help of this encryption and decryption, we will ensure the message is in a security purpose. What the sender sends and the receiver receives the message is equal by using this encryption and decryption techniques by matching the values. Okay, so encrypting we are using one formula C equal to m to the power e mod n. M is nothing, M is the plain text and C is the ciphertext. And decryption we will be using the private key. Decryption formula is equal to M equal to C to the power D mod M. Okay, C is the ciphertext and M is the recovered plain text. Okay, now we are going to see an example how this RSA works. How it is works. The first step we are going to choose two prime numbers p equal to 61, q equal to 53. Second, we are going to find the value n. So n equal to p into q, that is the formula. By applying the formula, we will get 3233 as the answer. The third step, we are going to find pi of n value. So pi of n equal to p minus 1 into q minus 1. So while we are producting these two values, we will get 3120 as the answer. So pi of n value is 3120. Next, the public exponent we are going to find that we can choose in the normal one, that we can randomly choose any values. The only one condition is the value has to be between the n value. The value should not exceed 3233. So the value must be 1 to 3033 and it has to be a prime number. Next one, we are going to find the private component with help of the Euclidean algorithm. Euclidean algorithm, nothing. We are going to find the GCD value. Okay, GCD value for what? With the help of the pi of n 3120 and with any one random key value, we will find GCD. The GCD has to be 1. So like that, while we are using here, we are selecting this. We are obtaining 2753 as the answer. So from this, we are getting 4 values. What are they? One is the n value, pi of n value, e value, d value. These are all the 4 values we come to know from this. So this is the key generation step. In this, we find the key value for private key, public key, then what is the modulus function, and what are all the Gaussian function. These 4 things we have completed in the key generation itself. Next, we will. So here we are going to see the encryption and decryption techniques, how it is works in the RSA algorithm. Okay, first here choosing the value, plain text value m equal to 65. This is based on our assumption, that is the original message what we are going to send to the receiver. How many characters are in that plain text, that denotes the m value. By applying this in the ciphertext formula, C equal to 65 to the power 17 mod 3233. While applying this in calculator, you will find the value as 2007 INT. This is the ciphertext value. With the help of the ciphertext value, we are going to find the plain text value with the help of the decryption formula. So decryption is converting the ciphertext to the plain text. So now here we are going to convert m equal to 2790 to the power 2753 mod 3233. While applying this in the calculator, you will find the value as 65. That is equal to the original value. So here the encryption works in a good manner. The plain text value here matched after decryption. So there is no third party interference in this message. Like this only we have to verify our message whether it is in secure manner, whether the message is transferred to the receiver in a good manner. Is there any decryption occur over there? Any third party users, any misuses, like them, we have to check with the help of the RSA algorithm. Okay, next up, applications of RSA. In where the RSA algorithm works, it plays a major role. Secure communication, digital signature, key exchange. These are all the 3 areas RSA algorithm plays a major role. Secure communication. Secure communication means the information what we are sharing in the net has to be in a protective manner, that is in a secure manner. With the help of the RSA algorithm, we ensure that the sensitive information such as the debit card, credit card details, personal data are transmitted securely without any default. The next one is digital signature. Digital signature. Nowadays, we are receiving all the certificates through the net without any manual signature or e-certificates. So, with the help of this RSA algorithm, we can use to sign documents to verify the authentication, whether the sign is authenticably and integrity of the message. So the next one is key exchange. So RSA facilitate the secure key exchange between the two parties. That is, exchanging a key in a channel has to be in a secure manner. These are all the applications of the RSA. Next, what are the strengths of the RSA? Okay, so high security. How can we say there is a high security? Means it provides a high level security of data transmission, especially when we are using the large key size, when we are selecting the large prime numbers, then the secure will be in a high manner. The next one is the asymmetric nature. So asymmetric nature, it eliminates the need to share the secret key securely, okay, which is an advantage over the symmetric encryption system, which is not used in the symmetric exchange. The next one is advantages and limitations. The advantages of RSA algorithm. It is simple to understand and we can implement in an easy manner. Then it provides both encryption and digital signatures. The limitations, while we are comparing RSA algorithm or asymmetric algorithm to the symmetric algorithm, the time will be taken as very high. It is slower. The process working in a slower manner since the computation process is taking few minutes. Then it requires large key sizes for adequate security. For adequate security, we have to choose the prime number in large manner, then only our secure will be in fine manner. These are all the advantages and limitations. So these are all the limitations of RSA which we discussed in the previous. These are all the futures of RSA. First one is in quantum computing, we can use the RSA algorithm. Then key sizes will be keep on increasing. It is an emergence algorithm for some other alternatives. Then hybrid cryptography systems, we can use the RSA algorithm. In digital signatures also, we can use the RSA algorithm. These are all the future of RSA. Next, as a conclusion. So, summary RSA. It is a cornerstone for modern cryptography. With the help of this RSA, the security can be balanced. And RSA is also in a simplicity manner we can use for many applications. So overall view today, what are all the things we learn? What is network security? What is encryption, decryption? RSA algorithm, how the RSA algorithm works and how it gives the security. Then in future, where the RSA algorithm can use. These are all the topics we discussed today. Thank you.